Now let's look at paired data with confidence intervals. So we're looking at confidence intervals for the difference of means, but this is going to yield one group. So we have the same conditions as before, random 10% in the large sample. However, it's important that we're looking at the difference. We're not looking at each group individually. We're taking those two and subtracting and looking at the difference of them. So the paired data needs to come from a random sample. 10%, the difference needs to be less than 10% of the population. And you still have your sample size, but we're just looking at the difference. Then for the formula for confidence interval, it'd be the average difference plus or minus your test statistic, and then your standard error is based on the difference group. So the data from the random sample of identical twins are shown again. Construct and interpret a 95% confidence interval for the true mean difference in IQ scores among twins raised in high income and low income households. So since we're looking at the difference, we're going to be looking at this fourth row right here. This is the data we need to be of interest, not the other two. So we're doing a 95% confidence interval for the difference, where the mu sub diff is the true mean difference, high income minus low income, in IQ scores for pairs of identical twins raised in separate households. It's important that you identify the order of subtraction because, again, positive versus negative results within the interval tells us something depending on how we subtract. So we're doing a one sample t interval for the diff of the mean, so not x1 minus x2, or sorry, mu1 minus mu2, but mu sub diff. We had a random sample of 12 pairs of identical twins, and we can assume 12 is less than 10% of all pairs of identical twins raised in separate households. It is a small sample, so we do have to graph, but it does not show any strong skewness or outliers. So x bar diff is 5.833. The standard deviation of that difference is 3.93, and there's 12 altogether. So our degrees of freedom is 11, and our critical value is 2.201. So doing the confidence interval by hand is 3.336 to 8.330. So we are 95% confident that the interval from 3.336 to 8.330 captures the true mean difference in IQ scores among pairs of identical twins raised in separate households. Going back to the do step of the problem, if you're doing your calculator instead of doing it by hand, notice this is all one sample. So you're just doing your confidence interval for t, a t interval.